In this module, we're going to be talking about atmospheric stability. Let's first consider a general definitions of what stability means. In this setup, we can see that there's a ball in a curved line like this, where if it is disturbed in either direction, it would have a tendency to come back into its mean position. This is called stable equilibrium. Similarly, for a setup like this ball will always move away from the mean position even if it's disturbed in either direction. This is usually termed as unstable equilibrium. While if the curve is actually a straight line, the ball would simply move to its new disturbed position and remain there. This is usually termed as neutral equilibrium. Given these definitions, we can construct the idea of what atmospheric stability means. In general, if this is an air parcel in the atmosphere, it would either move up or down depending upon what the temperature of this air parcel is, which in turn affects the density of this air parcel. If the temperature increases for this air parcel, the density would essentially decrease. Now, if the decrease is more than the surrounding air, then this air parcel would have a tendency to go up. Similarly, with the decrease in temperature, if the density actually increases, then the more dense air would tend to come back down to its original position. Based on these definitions, we can construct the idea of what atmospheric stability is. The adiabatic lapse rate is basically a constant rate of decrease in temperature as we move on in height. Usually, under dry conditions, the adiabatic lapse rate is 9.8 Kelvin per kilometer in the increase in atmospheric height. If we consider the air parcel following the atmospheric profile while the adiabatic lapse rate follows this line, then a small increase in the height of the air parcel would suggest that there is a decrease in its temperature. A decrease in temperature would actually increase its density, due to which the dense air would tend to come back into its original position. Similarly, in this direction, there is an increase in temperature which would decrease the density and hence making the air parcel move towards this mean position. This mean position is like a stable equilibrium position that can be thought of as this setup. On the other hand, if we have the atmospheric profile following a line like this, a small increase in height would actually increase the temperature of the air parcel, because of which its density would decrease and would make the air parcel move forward in the upward direction. Similarly, a decrease in height would make the air parcel go downwards. This is usually termed as an unstable atmosphere. In general, we would like our atmosphere to be unstable, because this air parcel would constitute different kinds of pollutants that we would want to move away from the lower levels of the atmosphere. Hence, an atmospheric profile like this would make it viable for these air parcels to move away to the higher levels of the atmosphere and not be retained in the lower levels, where the pollutants would be more difficult to get rid of. Thank you.